Let's do question number 4. So figure is given, the voltage is across resistor 1. So voltage across this resistor. So first question is, select state variables and derive an matrix form of circuit state space model. Okay, how do we select state variables? So the number of state variables are equal to number of reactive elements in a circuit. So if we have two reactive elements, reactive elements, capacitor and inductor, so we'll have two state variables. So if we assume the current through inductor is I, so I would be the state variable for inductor, and voltage across capacitor is UC. That is UC. So there will be two state variables. One will be for inductor, because for inductor are linked with current and capacitor is linked with voltage. So if you see, state variables are x1 is equals to I, which is current through inductor, x2 is UC, which is voltage across capacitor. So we have two state variables. So the next part is, how do we write the state equation? So to write the state equation, first we do is we apply Kirchhoff's voltage law across this loop. If you apply KVL across this loop, what you will get is U is, which is the input is, so the input voltage is equal to voltage drop across inductor, resistor and capacitor. So voltage drop across inductor is given as L di by dt. Here I is x1, so it's L x by x1 by dt, plus R, voltage drop across resistor is R I is x1, so it's x1. Voltage drop across capacitor is UC, but UC is x2, so we write this in this form. So if we take this to this side, after rearranging we'll get something like this. So this is the first equation, first state variable x1. Now if we look at this circuit, current in A, this point, so what's the, if you apply KCL here, so KCL is equals to current in this loop coming from here, I mean to this side, is equals to summation of these two currents. That means I total, which is coming from here, is summation of current through capacitor branch and current through resistor branch. So current through capacitor branch, so what is a current across capacitor? So current across